Alright, today's topic is linear equations, and the learning objectives for this set of notes here is to solve equations in one variable algebraically, solve a rational equation, find a linear equation, and given the equations of two lines, determine whether the graphs are parallel or perpendicular, and then write an equation of a line parallel or perpendicular to a given line. Okay, so you can find this material in our textbook, College Algebra, in sections 2.2 and 2.3. So definition here, a linear equation in one variable can be written in the form ax plus b equal to 0, where a, b are real numbers, and a is not equal to 0. And once again, the goal is to basically isolate the variable by itself and get it equal to some value. So let's go see several equations on how to solve them. So let's look at number 1 here. We have minus v minus 3 equals 17. So using our properties of numbers, or in properties of equations, that says if you could add or subtract on both sides, you can manipulate the equation and transform it to another equation. So let's go ahead and do this. So I'm going to go ahead and add 3 on both sides. Okay, because whatever you do to one side of the equation, as long as you do it on the other side, the equation is still balanced. Okay, so we get negative 4v equal to 20. All right, so now we have a simpler equation, negative 4v equal to 20. And now we solve that equation by dividing both sides by negative 4. Okay. And that will give us v equals 20 divided by negative 4, which is negative 5. And you could always check your solution to see if you didn't mess up by resubstituting back into the original equation. So for instance, when we plug it in, we get negative 4, right, times negative 5 minus 3. And the question is, does this equal 17? Okay, and we see that we get negative 20 minus 3 if we evaluate the left-hand side. But then we get negative, I need to have a calculation error there. We get positive 20. 20 minus 3 gives us a positive 17. So we get 17 equals 17, which is a true statement. Therefore, negative 5 is the solution. Okay, so I won't be checking all our equations, but you could always do that to make sure you get the solution correct. All right, number 2 here, we have a little work to do before we start isolating. We always want to simplify each side of the equation first before we start manipulating the equation to get x, or the variable by itself. So on the left-hand side, we have 3 times the quantity of x plus 4. And so we're going to have to distribute here. Distribute. So we get 3 times x, which gives us 3x there. And then we have to distribute the 3 again, times the 4 there to get 12. Okay, so we get 3x plus 12 equals negative 45. All right, so then we subtract 12 on both sides. And that gives us 3x equals negative 57. And now we divide both sides by 3, which tells us that x is equal to a negative 19. All right, number 3 here is somewhat like a fraction type of equation. I like to build up the common denominator. Some people like to multiply both sides of the common denominator by the common denominator. It's equivalent to how I'm doing it, but I like to visualize each element or each term in our equation as a fraction, and then find the common denominator between 1 and 2 there. And in this case, it's 2. So I multiply top and bottom of this fraction by 2. Since it doesn't have a denominator 2. So then we get negative 4 over 2 equals x minus 12 over 2. And now both terms on the left and right hand side of the equation have the same denominator. So then I like to say forget about the denominators. In other words, forget about it. And we write negative 4 equal to x minus 12. So that's equivalent to multiplying both sides by 2. All right, so now I'm going to isolate the x by adding 12 on both sides. And that would give us 8 on the left and x on the right. So we say 8 equals x, or x equals 8. Okay, that's our solution. All right, let's take a look at equation 4 here. Once again, we have some work on the left-hand side to do. We're going to go ahead and distribute. So we get 2 times 4r, which is 8r, and then 2 times 1 there, which is 2, plus 5r equals 93. All right, so the left-hand side, after we distribute, we see we have like terms. We have 8r and 5r, so those combine to give us 13r plus 2 equals 93. All right, so now we're going to subtract 2 on both sides to get 13r equals 91. And then we divide both sides by 13. And that will give us r equal to 91 divided by 13, which is r equal to 7. Once again, you can always check your answer by plugging it back into the equation. And it's to see you get a true statement. All right, number 5 here. We have parentheses on the left and also parentheses on the right. So we're going to have to do distributive property on both sides. Before we start manipulating any x's, we want to make sure we simplify the left and right hand side completely first. Okay, so we're going to go ahead and distribute here and here. So the left hand side, we're going to get negative 2 plus a 6 times 2, which is 12, minus an 18 because we have a 6 times 3x, so a negative 18x. The right hand side, we're going to distribute the negative 2. We get negative 2 times negative 3x to get a positive 6x. And then we have a negative 2 times a negative 5, which gives us a positive 10. All right, so on the left-hand side, we have like terms. We have a negative 2 and 12, so combining that gives us 10. So we have 10 minus 18x on the left. On the right, we have 6x plus 10. Okay, so then I'm going to go ahead and subtract 6x on both sides here. That gives me leaves me with 10 minus 24x on the left, and then 10 on the right. All right, so I'm going to subtract 10 on both sides. That gives us negative 24x equal to 0. And then divide both sides by negative 24. Gives us x equals 0. So we have a solution of x equal to 0. Okay, so the next equation, 3n plus 21 equals 3 times n plus 7. And so the left-hand side is already complete, but the right-hand side is not. We got to distribute, so we're going to distribute 3 to get 3n plus 3 times 7, which is 21. All right, you can see that the left-hand side and the right-hand side are identical. And so this is what we call an identity equation. In fact, if you go further and try to isolate this equation, in other words, to isolate the variable, I would subtract, say, 3n on both sides, and that would give me 21 equals 21, which is always true. Okay, so an identity basically is a statement that's always true. Okay, for all values of the variable except unless you have to restrict it for some reason. Okay. The next one here, we have this equation here that has a lot to do on the left, okay, the right hand side as well. So let's go ahead and distribute the 10. So number 7 here, we're going to distribute the 10 to get 10, and then 10 times negative 6p to get negative 6dp. And then to the next term, we distribute 10 into the parentheses to get 10 times 7p, which is 70p. And then 10 times the negative 6 to get negative 60. Equals 3. And then the right hand side here, we have like terms of p and 9p. So that gives us 10p. Okay, so let's go ahead and combine our like terms on the left. We do have 10 and minus 60. So that's going to give us negative 50. And then we have negative 60p and 70p. Those are like terms. So add those, we get 10p. Equals 3 plus 10p. Once again, if I subtract 10p on both sides to isolate the p, you'll notice that we get negative 50 equal to 3. And that is a false statement, which indicates a contradiction. Okay, in other words, it's not true. We call these type of equations inconsistent. And it's inconsistent equation because it doesn't have a solution. All right. So as you've noticed, sometimes equations have solutions, sometimes they don't, and sometimes they have an infinite number of solutions. Like this identity, there's an infinite number of values that satisfy that equation. Equations can be classified as one of three types. A little typo here. Okay, so equations can be classified as one of three types: identity, conditional, or inconsistent. So we have an identity equation, which is true for all values of the variable, and that's like equation number 6 that we just solved, or solved, and we saw that we got a true statement. A conditional equation is true for only some values of the variable, and that's like equations 1, 2, 3, 4, 5. In other words, we tend to have one solution or some solutions that satisfy the equation. And then the one that we just solved right now, which was number 7, is what we would call an inconsistent equation because it results in a false statement, a contradiction. Okay, so equations can be classified as one of those three. All right, we're going to take a look at rational equations. A quick example is a lot of rational equations result in a linear equation. So a rational equation is an equation that contains at least one rational expression where the variable appears in at least one of the denominators. Okay, so here we're going to solve the following rational equation. Okay, so I'll solve the equation for the given variable. We have 8 minus 3 over 5n squared minus 1 over n. We have 1 equal to 1 over 5n. So I like to build up the fractions so they have the LCD, and in this case the LCD of all the denominators would be 5n squared. And so if I took the first one, I don't need to do much here because it already has a denominator of n squared. But the second one here, I would multiply by 5n, top and bottom there, so this way I get a denominator of 5n squared. Alright, and then the 1 over 5n, I'm going to multiply top and bottom by n, so this way I could get 5n squared. Alright, doing so gives me 3n minus 3 over 5n squared minus 5n over 5n squared, all equal to n over 5n. Okay, and then I like to say forget about the denominators. Okay, so they're all the same now, and it's like multiplying through by the LCD, and that leaves me with n minus 3 minus 5n equal to n. Okay, so after we forget about the denominators, we have n minus 3 minus 5n equal to n. Combine our like terms, so we have minus 3 minus 4n equal to n. And then I'm going to add 4n on both sides to get negative 3 equals 5n. Okay, so now we could just divide both sides by 5. And that will result in negative 3/5 equals n, or n equals negative 3/5. All right, let's try another one. Let's look at number 9 here. Number 9, we also have 3 fractions here, and we want to identify the LCD here. And you can see the LCD is x minus 1 times x minus 2. So then we build up each of these fractions so they have an LCD denominator of x minus 1 times x minus 3. So the first fraction, 3 over x minus 2, already has an x minus 2. So we're going to multiply top and bottom of that one by x minus 1 over x minus 1. Okay. This equals 1 over x minus 1. So this one has an x minus 1 in the denominator, but it don't have an x minus 2. So we're going to multiply top and bottom by x minus 2. Okay. Once again, those values are just 1. And this last fraction already has the LCD, so we don't need to multiply anything top and bottom of. Okay, so then now we're going to get basically 3 times x minus 1 all over x minus 2 times x minus 1 equals x minus 2 all over x minus 1 over x minus 2 plus 7 over x minus 1 times x minus 2. Okay. And now we say forget about it. Forget about the denominators, and that leaves us with 3 times x minus 1 equals x minus 2 plus 7. Okay, once again, that's just like multiplying through the equation by the LCD. All right, now let's go ahead and distribute. So now we went from a fraction equation to a linear equation. And we're going to go ahead and distribute on the left-hand side here to get 3x minus 3 equals x minus 2 plus 7. So x minus 2, negative 2 plus 7 adds up to 5. Okay, so I'm going to go ahead and subtract x on both sides here to get 2x minus 3 equals 5. And then I'm going to go ahead and add 3 on both sides there to get 2x equals 8. And so divide both sides by 2. That gives us x equals 4. And then for rational equations, I forgot to mention earlier, is that you need to check the denominators. When you get the answer, the solution, you want to check that the solution doesn't make your denominator 0. Otherwise, you'll be dividing by 0, and it wouldn't have a solution. Okay, so in this case, if you check quickly, do a nice inspection there, you can see that 4 for number 9 here will not make neither of those denominators 0. And so therefore, it's a solution. All right, number 10 here. We're going to solve it very similarly, except this time, though, one of the denominators is not factored. So you want to make sure the denominators are completely factored. So I'm going to rewrite this equation as 6 over r plus 4 plus 7 over r times r plus 4. That's how r squared plus 4 are factors. And then that's equal to 1 over r. Okay, so the LCD then, in this particular case, is going to be r times r plus 4. I'm going to build up each factor so that it has a denominator of r times r plus 4. So I'm going to multiply this first one here by r. The second one doesn't need to be multiplied by anything, but the right-hand side should be multiplied by r plus 4. All right, so doing so is going to give us 6r over r plus 4. Then we have plus 7 over r times r plus 4 equals r plus 4 all over r times r plus 4. All right, and then we say forget about the denominators, forget about it. And we're left with 6r plus 7 equals r plus 4. And I'm going to subtract r on both sides, and we have the linear equation, so now we can manipulate it to get r by itself. So again, subtract r on both sides to get 5r plus 7 equals 4. Then I'm going to subtract 7 on both sides to get 5r equals negative 3. Divide both sides by 5 gives us r equal to negative 3 over 5. And that's your answer. You could do a quick eye inspection to see if negative 3/5 gives us anything, makes any of the denominators 0, and it doesn't, so it's a solution. All right, so that wraps up our solving equations that are basically the type of a linear equation, even though these were fraction equations or sometimes called rational equations, like 11, 12, like 9 and 8 here, and 10, but they result in a linear equation, and so those can be easily solved, like we solved the other ones. All right, so we're going to switch gears here. Okay, so we're going to talk about linear equations in 2 variables. Okay, some common things that we notice is that these are lines, and a line has what we call a slope. Okay, so the slope of the line M represents the change in y over the change in x. And you could find the slope of a line given 2 points, x1, y1, and x2, y2. And the formula for that is m equal to y2 minus y1 over x2 minus x1. So that's a useful formula to know to find the slope. But to comment on the slope, it's a measure of how steep a line is. Okay, and that's how you would find it if you have 2 points. But it's telling you the steepness of a line. Okay, so a linear equation in two variables can be written in the form y equals mx plus b, where m's the slope of the line, and 0 comma b, the order pair 0 comma b, is the y-intercept of the line. And so if we zoom in this picture here, let's take a look at the line y equals 2x plus 1. You can see that it has a y-intercept at 0, 1, and roughly it has a slope of 2. Meaning if I go up 2 spots, 1, 2, and then to the right 1, you'll be on the line again. Up 1, 2, to the right 1, you're on the line again. And then that's basically how we can use the slope to actually graph a line as well. But the point is that the slope tells you how much rise in y there is for every difference in x there. So how much y rise for a unit increase in x. That's how you might think of it as well. And you could tell by the slopes for each one of these lines which line is steeper. Okay, so if you look at the orange and green line here, we have a slope of 2 1/3. So the line y equal to 2x plus 1 is steeper than the line m equal to 1/3. However, we have a line y equal to negative 3x minus 2, and the slope there is negative 3. It's a negative slope, but it's steep as well. And that's steeper than the line y equal to 2x plus 3. It's just going in a negative direction in some sense, in the sense of for every unit increase in x value, the y value will decrease, okay, by 3. So that's a quick idea of the slope of a line. Hopefully some of this is reviewed. And this particular form of the line is called the slope-intercept form of the line. We got some typos there. Called the slope-intercept form of the line. And let's go ahead and use that formula here. M equals y2 minus y1 over x2 minus x1 to find the slope of the line passing through these given points. All right, so looking at number 11 here, we have, once again, we can say this is x1, y1, and this is x2, y2. It doesn't really matter what you label those points, as long as you're consistent with the form. All right, so we'd have m, the slope, would be 1 minus 0 all over 3 minus a negative 2. And this would give us a slope of 1 over 5, a positive slope. And so this would have a positive slope that would lean like that, pretty much. The next point, or the next pair of order pairs, is negative 1, 2, and 2, 2. All right, so the slope is 2 minus 2 over 2 minus negative 1. So you see we get 0 over a positive 3, which gives us 0. So a 0 slope. In this case, this would be a horizontal line because it has no rise. It's basically flat. And so if you were to plot a graph like this, you would see a horizontal line pretty flat, okay, because of the slope is 0. The next order pair is a pair of order pairs is 0, 4 and 1, negative 1. All right, so minus 1 minus 4 over 1 minus 0. And so we get negative 5 over 1, which gives us negative 5. So we have a negative slope. And it would lean somewhat like that in the negative fashion. Okay, so the next ordered pairs is 3, 4 and 3, 1. We have the slope equals to 1 minus 4 over 3 minus 3. So we get negative 3 over 0. In other words, we get an undefined slope. In this case, this will indicate we have basically a vertical line. Like the horizontal line, it has a slope of 0. A vertical line, it has an undefined slope. That means it's going vertically. That means you get for the change of y, you're not changing in x, therefore you're dividing by 0 all the time. So it's very steep. Okay, undefined slope. All right, so that's how you can use the the slope formula to find the slope of a line passing through 2 given points. The next equation, next thing we're here to do is determine the slope and y-intercept given the equation. Here, this is not much of too much calculation here, because examining the equation, we could see that the number in front of the x value is the slope. So the slope is going to be equal to negative 3/4. In other words, we have a rise of negative 3/4 for a unit increase in x. And then our y-coordinate of our y-intercept has the value that's not the x value, right? The number. And so the y-intercept there always has an x-coordinate of 0 and a value of negative 4. And if you wanted to graph this line quickly, we could quickly give a little sketch of this. Might look something like this here. Okay, so if I wanted to graph this, I could actually use the slope and the point 0, negative 4. So 0, negative 4 would appear here, right? And it has a negative slope of negative 3/4. So you could think of it as a rise of excuse me, I went blank there. A rise of 3 and a run of negative 4. Okay, depending on how you see it. But I could go up 1, 2, 3, and then a run of negative 4. So 1, 2, 3, 4. Otherwise, you could go down 3 because you have a what do you call a rise in this case, right? Negative 3 over a run of 4. So you could go down 1, 2, 3, and over 4. And basically, you connect the dots. And there you get a rough sketch of your line. Y equals negative 3/4 x minus 4. Okay, moving on to finding the equations of the lines now. So we have what's called the point slope form of a line. Typo there, form of a line. Okay, which is equal to the equation of the line with slope m passing through the point x1, y1 is y minus y1 equals m times x minus x1. So find the slope-intercept form of the equation of the line. A couple typos here. Yeah. Line that has a slope of 3 and passes through the point 1, negative 2. Okay, so first thing we do is find the slope. We identify the slope, which is 3. And then, of course, our point is 1, negative 2. Okay, so our equation is y minus y1 equals m times x minus x1. All right, so this will be x1 and this is our y1, so we have y minus a negative 2. Okay, equals our slope of 3 times x minus 1. Okay, so on the left-hand side, we're going to simplify to get y plus 2. The right-hand side, we get 3x plus or minus 3. And then we're going to subtract 2 on both sides there. So we can isolate the y to get 3x minus 5. And so the line with slope of 3 passing through the point 1, negative 2 is the line y equals 3x minus 5. And you could quickly check on decimals here. If I graph the line, y equals 3x minus 5, you can see it passes through the point 1, negative 2, which would be right there. And I can't click on it, but if I graph the point, it should appear in the line. There it is. Okay, so that point is 1, negative 2. Okay. All right, so next concept here are parallel and perpendicular lines. Two distinct non-vertical lines are parallel if and only if their slopes are equal. And so if you have one line that's slanted like this, and basically another line that did the same thing at the same slope. So this is line 1 and line 2, which line 1 had slope m1 and line m2, then we would say line 1 is parallel to line 2 if and only if m1 equals m2. Okay. Perpendicular lines are, two non-perpendicular lines are perpendicular if and only if their slopes are negative reciprocals of each other. So perpendicular lines meet or cross at a point, but their meeting point of where they cross, they meet at a 90-degree angle. Okay, so if this is line 1 with slope 1 and line 2 with slope 2, then we say L1 is perpendicular to L2 using that symbol if and only if M1 times M2 is equal to negative 1. They're negative reciprocals of each other, which means M2 is negative 1 over M1. Okay, let's see a problem that illustrates this concept. So number 17 here, we're actually finding the slope-intercept form of the equations of the lines that pass through the point 2, negative 1 and are parallel and perpendicular to the line 2x minus 3y equal to 5. Okay, so the portents of the 2x minus 3y equals 5 is that we're looking for a line that's parallel to 2x minus 3y equal to 5 that passes through point 2, negative 1, and then also a line that's perpendicular to 2x minus 3y equal to 5 that also passes through the point 2, negative 1. Okay, so to do this, we need to isolate the y from this equation to determine the slope of this line. Or you could find 2 points on the line and then use those 2 points to get the slope, however you want to do it. But I'm going to isolate the variable y here. So I'm going to subtract 2x on both sides. So doing so gives me negative 3y equals negative 2x plus 5. Okay, and then I'm going to divide both sides by 3, so I get positive 2/3 x minus 5/3. All right, so what do we get out of this here? We're going to get out of this that this line has a slope of 2/3, and we're going to need that slope to find the line parallel to it and perpendicular to it that passes the point 2, negative 1. All right, so for the parallel point part here, we know we're going to use our equation, the point slope form of the line, y minus y1 equal to m times x minus x1 to get that line. So we're going to get y minus a negative 1, which equals the slope. We're going to take it to be the same because we want it to be parallel. So that'll be 2/3 times x minus x1. x1 is 2, so x minus 2 there. So we have y plus 1 equals to 2/3 x. After I distribute there on the right, plus or minus 4/3. And then we subtract 1 on both sides. So we get y equals 2/3 x minus, build up, minus 4/3 minus 1/3. Minus 1 is going to be 7/3. And that's our line. Okay. So this line would be parallel to the line 2x minus 3y. All right, and then our other point line, we want this to be perpendicular. Okay, so same equation or slope form of line that we're going to use to find the equation. The difference here, though, is that we're going to plug in the point again, except the slope this time we want it to be the negative reciprocal of 2/3. So that means the negative reciprocal of 2/3, right? 2/3 times third m equals -1. So that means m equals -1 over 2 over 3, which is equivalent to saying -3 over 2. So that's the slope we need. Okay, so we get y plus 1, and then we distribute here to get -3 over 2x plus -3 over 2 times a -2, so it's plus 6 over 2, which is just 3. So y equals -3 over 2x plus 2, because you would subtract 1 on both sides here. Okay, so we get this line here that passes the point 2, -1, and perpendicular to the line 2x minus 3y. All right, let's go back in decimals to kind of verify that's the case. So let me get rid of this here. All right, so the equation that we had was 2x minus 3y equals 5. Okay, so that's the slope that we want. So the parallel line that we're going to graph is the y equal to 2/3 x minus 7 over 3. Okay, so you can see it's parallel to it. And it passes through the point 2, -1. Okay, so that's the purple line. So it's parallel to the green line. Okay, purple line passes the point 2, -1. Now we should see the other line that we find to be perpendicular. So it's going to shoot across like this, where it meets at a 90-degree angle. So it's actually going to be perpendicular to both of these lines. All right, and that line was y equal to a -3/2 x plus 2. And you can see that it also passes the point 2, -1. There you go.